I want to do a quick recap of the classical closed economy model that Mankiw develops in Chapter 3. And this model starts with a set of equations. The first equation is that GDP, Y, is equal to F function of capital and labor. Capital and labor are in fixed supplies, so that's why GDP then is fixed. So the assumption here is that all factors are used efficiently in the economy, and there's no unemployment or idle capital in the economy. So you have GDP being equal to its potential. Is a word that we often use a lot in economics. Potential GDP is the level of GDP when all factors of production basically are being employed. Kind of a loose definition. The second set of equations for our model consists of the national income accounts identity, which says that GDP is equal to the sum of its components. In a closed economy, this is consumption plus investment plus government spending. And it's important to remember that this investment is real investment, not financial investment. So it's real investment, not financial. It's investment in buildings, in factories, in equipment, etc., not in assets. So with these we add a consumption function where consumption depends as a function C of GDP minus taxes, so this is disposable income, and investment depends on the interest rate. Is our other behavioral equation, and then we put all those together and we end up with GDP is equal to consumption, which depends on GDP, which is fixed because we're assuming efficiency, minus taxes, so it's disposable income. We'll assume taxes are fixed for now. And investment depends on the interest rate, and government spending is fixed for now. So this is our model. It's as I said, it's a one equation, one endogenous variable, which is the interest rate. If we rearrange the equation, we get y bar minus c minus g equals IR, and we can interpret this as savings. And we saw in class how we could break that down into private savings and government savings. So savings has to be equal to the level of investment, and it's the interest rate again that adjusts so that investment equals savings. So we can represent this. So we just write that as S. We can. This is a number, some number. Because all these things are fixed outside of the model. So if we graph it, we have the level of savings is independent of the interest rate by definition, by assumption. We assume that savings doesn't depend on the interest rate. Savings is the difference between GDP, which we've assumed to be fixed by the factors of production, minus consumption minus government spending. So that's what savings is. Then we have a downward sloping investment function. The higher the interest rate, the more expensive it is to borrow to finance a factory, and so the less investment there will be. And then we say that in this, what's sometimes called the loanable funds market, is how we can interpret what this graph is. The savings that are available from people to be invested, the interest rate will adjust so that the level of demand for those loanable funds is equal to the supply of the loanable funds. The supply is just fixed at S. So we get an R star. That's the level of the interest rate. If savings declines for some reason, so that people want to consume more, or the government increases its spending, there are fewer loanable funds available, then the interest rate will rise and investment will decline. And investment has to decline by the same amount that savings decline. If for some reason savings goes up, government reduces its deficit, or individuals decide they prefer to wait and consume in the future, then there's more loanable funds available, and so the interest rate drops down to, say, R2, and investment goes up. And that's the basic model. There isn't really anything else of interest. What the model does that's useful is it gives us a sense of potential GDP, and that's going to be important. The model also tells us that there's an important identity of savings equals to investment that is going to be the case in any economy, so we can sometimes think about the economy by looking through that lens. And the model also introduces us to the notion of crowding out, that when at the aggregate level one component of GDP increases or changes for exogenous reasons, that quite likely in many of the macroeconomic models what will happen is another component declines. And that crowding out is going to be a metaphor, right, for describing what goes on in the macroeconomy. So that's it for the classical closed economy model.